For lesson 2 on adding and subtracting radicals, we want to make sure that we are always adding and subtracting our coefficients of our like terms, which are ones with the same radical, but then not actually changing our radicals. So if we look at the first 3, they all have the same radical. So the first thing we want to do is just get into our adding and subtracting of our coefficients. So 8 plus 9 gives us 17, and we're going to keep our radical 3. In the second one, 6 minus 4 gives us 2, we're going to keep our radical 7. We want to remember, the last one, if there's no number in front, there's really an invisible 1. So 8 radical 6 minus 1 radical 6 gives us 7 radical 6. As we move down now, what we need to do is we need to simplify them, and sometimes we have to simplify both so that they end up with the same radical underneath. 72 is really 36 and 2, so we get 6 radical 2, plus 18 is really 9 and 2, and that gives us 3 radical 2. So we add the 6 and the 3 to get 9 radical 2. And we're just going to continue with this process the entire time. And I'm sure some of you are probably going through this rather quickly. And as we get through this piece, you'll start to see that you really start to memorize some of the ones that you've seen a whole handful of times. So 63 is 9 and 7, 28 is 4 and 7. So 3 radical 7 minus 2 radical 7 gives us either 1 radical 7 or just radical 7. And we're going to continue with this process for a little while as we go through it. So square root of 180 is the square root of 36 and 5. And 80 is the square root of 16 and 5. So 6 radical 5 minus 4 radical 5 is actually going to give us 2 radical 5. Got to pay a little more attention to number 8 because it's got the 2 out in front. But we're just going to keep simplifying the same way that we already know how to do. This one's going to be a little interesting in how it finishes, though. And the fact that we end up with 4 radical 2 minus 4 radical 2. Well, 4 minus 4 is 0 radical 2. And if you remember, the operation is multiplication, so 0 times anything is 0. 54 is 9 and 6, gives us 3 square root 6. 24 is 4 radical 6, we'll keep that 3 in front. We get 3 times 2 radical 6, which gives us 6 radical 6. Add them together to get 9 radical 6. Got to be a little more careful with variables. So we have to see the 81 is perfect, but the square root of x is not. So the 81 is a 9, but the square root of x just stays. Same thing here, the square root of 9 is 3, but since x is not a perfect square, that has to stay inside. So we do 9 plus 3 to get 12, and then the square root of x. Same thing here in the middle. The only difference is we have to split the 45. 9 and 5 gives us, not 4, gives us 3. And the square root of 5 stays inside along with the y. So same thing here, the 20 splits into 4 and 5. We get 2 and then 5y. So we have to make sure our 5 stays inside the radical, but since our y's are not perfect squares, they also have to stay inside. So 3 square root 5y minus 2 square root 5y gives us 1 square root 5y, or in other words, just the square root of 5y. So I have to take a little bit more attention here. We don't have to split the 9 because it's outside, but we get 9 and then we get square root x squared and square root x, which gives us 9x square root x. Here, we know our 9 is going to pop out because we know the square root of 9 is 3. So we're just going to worry about simplifying our square roots the way we normally do that. So we get x squared and x, and then again our 3 is going to come outside because we know the square root of 9 is perfect. Then we get 3x square root x. So we do 9x minus 3x, we get 6x square root x. So for these, we're just going to focus on making sure we get them all simplified as possible, and we'll see what our square roots are left with at the end. 700 is 107, which gives us 10 square root 7. the 8 square root 7 is simplified. So then we get negative 3 and then 4 square root 7, or square root 4 square root 7, excuse me. And we get negative 3 times 2 square root 7, which gives us negative 6 square root 7. So now they're all square root 7, so 10 plus 8 is 18. 18 minus 6 is 12 square root of 7. For the 160, we are going to be square root 16 square root 10, which gives us 4 square root 10. For the 40, we're going to be square root 4 square root 10, so that's going to be minus 2 square root 10. And for the 90, we're going to be square root 9 and square root 10, which gives us plus 3 square root 10. So all our radicals are the same. 4 minus 2 is 2, plus 3 is 5 square root 10. We'll keep going with the same process. Again, we might run into a situation where one of the square roots is different. So the 50 is square root 25 square root 2, gives us 5 square root 2. 98 square root 49 square root 2, so we're minus 7 square root 2. And 128 is going to be square root 64 and square root 2, which gives us plus 8 square root 2. So all the same again. 5 minus 7 is negative 2. Negative 2 plus 8 is 6 square root of 2. So we'll continue our process here. Square root of 125 is 25 and 5. So 5 square root 5. 12 is square root 4 square root 3. Gives us 2 square root 3. So we see for the first time we have some different radicals. 45 is square root 9 square root 5. So minus 3 square root 5. And 75 is 25 and 3. So plus 5 square root 3. So we only want to make sure that we are combining the ones that actually have the same radicals. So 5 square root 5 minus 3 square root 5 is 2 square root 5. And then 2 radical 3 and 5 radical 3 gives us 7 radical 3. And remember, when the radicals are different, we are just going to keep them separate. Which expression is equivalent to the sum of square root 600 and square root 400? So we really have this square root 600 plus square root 400. 600 is 106. 400 is 100. Actually, I take that back. 400 is a perfect square. That just gives us 20. And you would have figured out that you had square root 100 and square root 4, which are both perfect squares. And that's usually a dead giveaway that we have a perfect square originally. So we have 10 square root 6 plus square root of 20. Since those don't have the same radical, actually the 20 doesn't have a radical at all, they can't combine, they have to stay separate. For the last one, we're going to find a couple of perimeters. So we got to add up all the sides, so we'll focus on the triangle first. So we always want to start by simplifying. So 75 is square root 25 square root 3, 5 square root 3. 27 is square root 9 square root 3, 3 square root 3. And 48 is 16 and 3, 4 square root 3. So, luckily enough, these all have the same radical. So when we go to add them together and find our perimeters, we are going to be able to add them all together. 4 plus 3 is 8. Or excuse me, 5 plus 3 is 8 plus 4 is 12 square root 3. And then our last one, we only have to simplify a couple of them. So 50 is 25 and 2. So 5 square root 2. 72 is 36 and 2. 6 square root 2. And obviously our 6 and 8 don't combine, or don't simplify, I should say. So we get 6 plus 8. Those will go together, and then plus 5 square root 2 plus 6 square root 2. So 8 and 6 is easy, that becomes 14. 5 square root 2 plus 6 square root 2 becomes 11 square root 2. And because one of them has a radical and one of them does not, we know those are going to stay right there. And that's going to be our homework on adding and subtracting radicals.